Isaac Newton, most would say, was the greatest scientist ever to live. We are here to carry out his legacy by teaching you about the most famous laws, the first, second, and third laws of motion. My name is Dr. Veeve, and this is my colleague,
Dr. Lee. We are going to begin by telling you about the incredible first law of motion. So here is Dr. V with all you need to know.
Thank you, Dr. Lee. Now, you may be wondering, what is the first law of motion? Well, the first law of motion is described as Newton's first law of motion states that an object at rest will remain at rest, and an object in motion continues its motion with the same speed and direction unless acted upon by an unbalanced force. This law is often called the law of inertia. This means that there is a natural tendency of objects to keep on doing what they are doing. All objects resist changes in their state of motion. In the absence of force, motion will maintain its state. Now we will go over to Dr. Jacob with a fascinating experiment involving the first law of motion.
This is the egg drop experiment based off of Newton's first law of motion. The supplies needed are an egg, toilet paper roll, a pan, plastic cup, and food coloring. This experiment will be done by Jacob, our demonstrator.
As Jacob applies force to the pan, the egg's support is gone, and rather than following the pan, it falls into the cup because it has inertia and wants to stay in place.
Now that we've learned the first law of motion, we obviously need to learn the second, am I right? The second law of motion states that the rate of change of momentum of an object is proportional to the force acting upon it. Newton's second law of motion is altered, so the rate of change of momentum equals the force. Because momentum is the product of mass and velocity, the momentum change can result from either a change of mass or of velocity, or both. Now we will hand it over to Dr. Jacob with yet another experiment. This one will describe the second law.
This experiment will be based off of Newton's second law of motion. The supplies needed are a pie pan or other dish with sides, flour, hot chocolate mix, 3 sizes of marbles or rocks, and a spoon.
Acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object.
Thank you for that wonderful demonstration. Now, finally, we must learn the third and final law of motion. We will now hand it over to Professor Sam.
Thank you, Dr. Veeve. Now the third law of motion is... Newton's third law of motion states that for every action there is an equal and opposite reaction. The statement means that in every interaction, there's a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object.
Very interesting. And now, Dr. Jacob with another experiment to describe the third law.
This experiment will be based off of Newton's third law of motion. The supplies needed are a balloon, straw, tape, and string.
When the balloon is released, the air flows out. That is the action. Then the balloon accelerates forward. That is the equal and opposite reaction.
Now that we have learned about all the laws, we will describe important words you may need to know. Force is a push or pull on an object.
Work.
Work is the force that is applied to an object that moves the object.
Inertia.
Inertia is the tendency of an object to resist a change in motion.
Momentum.
The product of the mass and velocity of an object.
Positive acceleration.
Positive acceleration is an increase in the magnitude of the velocity of a moving body or an increase in speed.
Negative acceleration.
Negative acceleration is a decrease in the magnitude of velocity of a moving body or a decrease in speed.
Coefficient of friction.
The value between 0 and 1 describes the degree of interaction between two surfaces.
A change in the position of an object with respect to time, also on its reference point. Velocity.
Velocity is the rate at which an object changes its motion.
Something has changed within me. Something is not the same. I'm through with playing by the rules of someone else's game. Too late for second guessing. Too late to go back to sleep. It's time to trust my instincts. Close my eyes and believe. It's time to try defying gravity. I think I'll try defying gravity.
Wow.
It'll be like force.
No.
Yeah.
Force!
Just be really loud. Force!
Get it.
It's your line.
No, it's not.
You're using force.
I thought you're reading this. When should we do that?
Push it. Push it real good.
Can I be John?
And this is my something, I don't know.
Now that we've learned the first law,
Thank you.
Force is a pusher.
Inertia!
Inertia is the tendency of an object to resist the change in motion.
Inertia!
Inertia is negative acceleration.
That's not what you're saying. We're saying
Work! Help!
Positive acceleration.
I'm not saying it.
Wow.
What is disappointment? He's an old man.
Oh
my god!
Sam, did you get wet?
That's a wrap.
Thanks for watching.